Welcome to Lasea class. I am your teacher, Jan Lasea.
A blessed day to everyone! Today, I would like to share my knowledge, skill, and experience in assembling the OTTO Robot for the Arduino Nano microcontroller. The OTTO Robot is an open source robot with an epic personality, a true companion for learning technology and creativity. OTTO DIY Robot is a 3D printable open source robot. You can visit this website where you can download the 3D files and print it with your 3D printer device. The features of the OTTO Robot are the following. It can walk and dance, and it can avoid obstacles because it has a ultrasonic sensor that serves as its eyes. I do not have a 3D printer, but I bought these OTTO Robot body parts or shells online. The body part materials are high quality, made in China because it has no visible creases. I guess it is not 3D printed, but it is casted or molded with PVC plastics. I bought this supporting microcontroller and electronic components online. The Key Studio Electronic Parts DIY Kit for OTTO Robot Maker. It has a Arduino Nano microcontroller that serves as the brain of the OTTO Robot. The Key Studio provided lots of learning materials for assembling the OTTO Robot, and you can visit this website and download those resources. To program the OTTO Robot to walk and dance, we need to install this OTTO DIY library by Camilo para Palacio. In your computer, you must connect to the internet. And then you run the Arduino IDE, click the Manage Libraries onto the left panel, and then type the keyword OTTO DIY Live to search. And then, upon searching that OTTO DIY Live library for the OTTO Robot, you click the Install button. You must calibrate the 4 servo motors to point to 90 degrees before you completely assemble the entire parts. First, you need to connect the leg right servo motor to the Arduino Nano pin number 3. Next, you need to connect the leg left servo motor to the Arduino Nano pin number 2. Next to that, you need to connect the foot right servo motor to the Arduino Nano pin number 5. And then finally, you connect the foot left servo motor to the Arduino Nano digital pin number 4. Note that the BCC red wire of the servo motor must be connected to the 5 volts, while the brown wire is the ground, and then the orange wire is the control that you can control the servo motor to rotate to 90 degrees. This is the wiring diagram provided by the Key Studio that you need to follow. There is a Arduino Nano um, expansion board where you place the Arduino Nano microcontroller on top. And then it provided a lot of pins that you can easily connect those wires. The challenge in assembling the OTTO Robot is the soldering of the wires. You must solder the wires from the battery holder to the switch and then the Arduino Nano microcontroller. Follow the wiring diagram located at the left below, which is this diagram. First and foremost, you need to identify the two pins from the switch using a multimeter. If this identified two switch using the multimeter uh, has a closed circuit, therefore, that's it. You already found the two pins that when you push the switch, the the positive electricity 5 volts will flow to that red wire, and then the other wire or the other pin of the switch will be connected to the voltage input pin of the Arduino Nano extension board, whereas the ground coming from the battery holder will be connected to the ground pin of the Arduino Nano extension board or the expansion board, and it must be soldered, and that is the quite difficulty. There are two identified difficulty here is the first one, you need to identify the two pins that will serve as the closed circuit pin whenever you push the switch to turn on. And then secondly, the challenge or the second difficulty challenge is the soldering of the wires. And the picture on to the right is the finish soldering of those red wires and black wires coming from the battery holder to the switch and then to the Arduino Nano expansion board. I modified the example codes and provided this file, OTTO Robot.ino, that demonstrate the OTTO Robot to do the following. It will walk backward, followed by it will walk forward, and then followed by stationary run, and then followed by moonwalk, and then followed by cross. And then it will repeat again from the start, which is walk backward repeatedly. Ladies and gentlemen, these are the parts of the K Studio OTTO Robot Maker Kit. First, we have the Arduino Nano microcontroller. Next, we have the Arduino Nano Shield, ultrasonic sensor, Bluetooth module. We have a active buzzer. Next, we have the self-locking push switch. Next, we have 4 micro servo motors. We have small screws, jumper wires. Next, we have that 4 1.5 volts AA battery holder. And then we have this USB cable for the Arduino Nano microcontroller. And then we have this Phillips screwdriver. And then finally, we have this manual where we can learn how to assemble the OTTO Robot. The Key Studio OTTO Robot Maker Kit does not include the parts of the OTTO Robot. The parts that I'm referring to are the chassis or the shells. That's why these shells or body parts of the OTTO Robot, I uh, I do not have yet a 3D printer, but there is a seller online that sells the 3D parts or the body parts of the OTTO Robot. And then the body parts of the OTTO Robot that I bought are quality because you cannot see any lines. Um, the quality is smooth. The way how it was made was smooth. Unlike in a using a 3D printer, that the quality is not that smooth. There are some lines that you can see in a output of a 3D printer, but this one, I think it was not 3D printed. It was manufactured using a machine that use a PVC plastic. So the body parts of the OTTO Robot are the following. We have the head where we can insert the ultrasonic sensor. Next to that, we have the body of the OTTO Robot where we can place the legs, and also we can place inside the Arduino Nano Shield together with the battery holder and servo motors. Next to that, we have the two legs of the OTTO Robot. And then finally, we have the 2 feet of the OTTO Robot. It took me 1 day to assemble the OTTO Robot kit.
Ladies and gentlemen, let us run and test. Let me turn on the switch.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.